This class we work out two problems. First problem is a coil is connected in parallel with the capacitor. Coil resistance is 20 ohm, inductance is 200 millihenries. Resistor is 5000 ohms. This combination is connected in series with the resistor, that the resistance is 5000 ohms. Supply voltage is 230. Resonant frequency is 10 power 3 kilohertz. The question is calculate the value of C, calculate XL, calculate dynamic impedance Z0, calculate quality factor, and also calculate the supply current. The resistance is connected, this combination is 5000 ohms. Coil resistance is 20 ohms. Coil inductance is 200 into 10 power minus 6 henries. Resonant frequency is 10 power 3 kilohertz. Now you calculate XL. XL is equal to 2 pi F into L. XL is equal to 1256.64 ohms. Here the resistance value is very less compared to XL. We neglect the resistance. Now the resonant frequency will become 1 by 2 pi root L by C. Actual resonant frequency is 1 by 2 pi L root L by C minus R square. We are neglecting it. Here this is 20, this is 1256.64 ohms. So F naught square is equal to 1 by 4 pi square L into C. We can calculate C. C is equal to 126.65 into 10 power minus 12 farads. We know the value of L and C and resistance. Now we calculate the dynamic impedance. Z0 is equal to L by RC. So substitute all the values. Z0 is equal to 78,957.76 ohms. Next we calculate the quality factor 2 pi FL by R. So F is the resonant frequency, L is equal to 200 into 10 power minus 6, R is equal to 20. Quality factor is 62.83. We have to find the supply current. First we have to calculate the total resistance in the circuit. The dynamic impedance is 78,957.76. This resistance is 5000 ohms, that is equal to 83,957.76 ohms. That is the total resistance in the circuit. The supply voltage is 230, supply current is equal to V by R. Supply current is 2.739 milliamps. The second problem is an inductor, capacitor and a conductance. All are connected in parallel. The supply current is 2 milliamps. Conductance value is 2.5 micro mho. Inductor value is 2 millihenries. Omega naught is equal to 5000 radians per second. When I is equal to 2 milliamps at a frequency of 5000 radians per second, first question is what value of C the voltage is maximum. Second question is what is the value of I for the inductor current to be 1 amps. That is the question. We know that conductance G is equal to 1 by R. I convert it to resistor. Instead of conductance, I convert it to resistor. So resistor value is 0.4 into 10 power 6. Omega naught square is equal to 1 by LC, we know it. C is equal to 1 by L into omega naught square. Now I can calculate C is equal to 20 microfarads. So the capacity value is 20 microfarads. At a frequency of 5000 radians per second, current flow through the supply current is 2 milliamps. Okay. Under the resonant condition, current flow through the conductance or resistance V is equal to I into R, or V is equal to I by G. That is equal to 0.4 into 10 power 6 into I volts. When I is equal to 2 milliamps, we get a maximum voltage. Maximum voltage is 800 volts. I is given 2 milliamps. Now we calculate XL. XL is equal to omega naught into L, that is equal to 10 ohms. The second question is current flow through the inductor is 1 amps. Here 2 milliamps. What would be the current, supply current? Here the parallel circuit, current magnification. This is in milliamps, this is in amps. So IL, current flow through the inductor is equal to V by omega naught into L. V is equal to 0.4 into 10 power 6 into I divided by 10. Omega naught into L is equal to 10. IL is given 1 is equal to 40,000 into I. I is equal to 1 by 40,000, that is equal to 0.025 milliamps. We want 1 amps current flow through the inductor, supply current to be 0.025 milliamps, capacitor value is 20 microfarad, maximum voltage is 800 volts. This way you have to work out this problem. With this, I conclude my lecture. Thanks for listening.